All right, let's suppose we have two groups of students. One group is going to get these extra math activities and another group is not. So they're just going to kind of run along with the usual curriculum. They're not really losing out on anything. We're trying to figure out if, though, there's some kind of difference in these test scores that they're going to take afterwards for students who have these activities versus those who are not given them. So all of the crucial information is given in the table there for each group. And we want to find, at this point, a 90% confidence interval for the difference in their average test scores. So this is definitely a two sample situation, right? The first sample is students with activities. The second is those without activities. So it would be fine if they had the same sample size, but it just so happens we have two different sample sizes. Certainly we have different means and different standard deviations, as is to be expected. Let's figure out how we would do this in our calculator. So if we go to stat and then over to tests, we know that the first 6 items there are hypothesis tests of various sorts. We want to do a confidence interval. So if we scroll down, right, we see Z interval, and then we'll see some other things below that, T interval, some two sample stuff, some proportion stuff. Since we are looking at two samples, I guess that means we're looking at two samp Z interval, two samp T interval, or two prop Z interval. We want to narrow down from there. We have X bar values, right? Average test scores. So if we're talking about averages, we're definitely not doing proportions. So, okay, I guess two prop Z interval is out. So then we have to decide, is this a two sample Z interval or a two sample T interval? The distinction is, do we have S or do we have sigma, right? Sigma is for the population. There's not really a reason for us to know that value. So the Z interval is kind of a thing generally of the past, right? Realistically speaking, we're more so going to know the sample standard deviation, S, and that's exactly what we have. So we're going to use a T interval when we know S. So we have two sample T interval. We could, if we had all of the raw data, we could put those into two different lists and use the data, but here we've got stats. So we have X bar, S, and N for both samples. So we just kind of go through. Now make sure that you're careful about the order in which you're doing these. The table lists N first, but two samp T intervals asking for X bar first. So for us, that's 71.4. S is the next thing listed, that's 4.5. And then N, again, this is first in our table, but it's the last of the things that were asked in our calculators. So that's 47. Again, run through the same thing with the group without activity. So 68.2, 6.6, and 38. So that's just a matter of kind of copying everything in the right order from the table. And then, of course, like usual, if we have a confidence interval, we need to know what's our confidence level. So we're going to say 0.90 for 90%. Pooled, we generally say no unless otherwise told. So for this class, again, just assume we're generally saying no, and then we calculate. And so our confidence interval is going to be, I'm just going to round a little bit here. So I'm going to say 1.1 to 5.3. And remember that this confidence interval gives us a little bit more information than maybe we think it does. So it gives us a lower bound and an upper bound, but it also tells us, you know, if we wanted to find our point estimate, right? This is basically x1 bar minus x2 bar. Well, there's a couple ways to do that. The first way to do that is just to subtract the values given in our calculator. So 71.4 minus 68.2. That's one way to do it, right? So we could do that. Let's see, we get 1, we should get 3.2. The other way to do it is to use our upper and lower bounds and just say, well, okay, let me take the average of those. So 1.1 plus 5.3 and then divide by 2. And again, we should get 3.2. So those are two different ways to find the point estimate. Right, the first way also we could have found from our table. We have those X bar values. We can also find the margin of error, right? That's just the upper bound minus our point estimate. The point estimate should be in the center of our interval, so nothing too crazy there. So a margin of error is 2.1. We could certainly go through, find our t-critical value, and divide this margin of error by the t-critical to find our standard error. But we also have all the pieces we would need for standard error. So there are other things we could calculate by hand, but this is certainly one way to go. Now, if we scroll down, notice in the 2-sample t-interval, it does have an arrow here. So there's other stuff we can scroll down and just verify, but it's just going to give us our sample sizes. So nothing too crazy there. That might be helpful if you're using lists, though, just to make sure you had the right sample sizes.